Hi, dear students. The topic of today's session is logic gates symbol and how can we construct a logic circuit from logic gates. So let's start our today's session. In today's session, first of all, we will learn about basic symbols of logic gates. So you can see on the screen that there are 6 basic logic gate symbols, and what we are going to do, I'm going to draw it for you again so that you can retain the concept more precisely and accurately. So there are 6 logic gates in our IGCSE syllabus, although these are also helpful for A-level students and O-level students. So let's start. First gate that we are going to use for constructing a logic circuit is NOT gate. So how I am going to draw it, it's just a triangle and a knot in front of it. So as in computer science, we used to perform three operations. One is input, then process, and then output. Same is the case in logic gates as well. You can see here we are having an input A, and then process is going to be done in this NOT gate, and then we are having an output X. Alright, so this is the structure of NOT gate, and NOT gate is also known as switching gate or inverter. What is the meaning of inverter or switching? We will learn about this thing when we will practice the truth table of NOT gate, right? What is truth table? We will learn about it later on, but right now, let's proceed further. Next gate is AND gate. So in order to memorize that, what should be the structure of AND gate? What is the tip I use to tell my student that you need to draw a D. That is the ending letter of word and this is the shape of AND gate as well. So we are having two inputs and one output. In that case, A and B are inputs and X is output. AND is multiply operation. So we usually write Boolean expression for this AND gate somewhat like this. X is output and we are going to multiply A dot B and then we will acquire the result for AND gate. Next is our OR gate. OR gate is again a gate that accepts two inputs. This is the way to draw it, that a circular surface or a curved surface and then a pointed one, then there is one output, right? So two inputs, A and B and one output. And OR gate is very simple, that it's an addition operation. So how are going to write the Boolean expression for it? X is equal to A plus B. Got it? Next is NOR gate. This is again the combination of NOT and OR. So you can see here by combining these two words we are getting this gate, NOR gate. So how are we going to draw it? We are just going to draw the symbol of OR and then we are going to put a NOT in front of it. So A, B and NOR gate, so we have an output X. So as we know that simple Boolean operation of OR gate is A plus B, and when we are going to apply NOT on it, then it will become X is equal to A plus B bar. Okay, next is our NAND gate. So definitely you will be getting it that it's not AND. It is the combination of two words not and AND. It makes NAND. And again we are sending two inputs to the gate and one output. So very simple AND gate and we are drawing a NOT in front of it. Two inputs and we are having an output X, right? Very simple Boolean expression. X is equal to A dot B and then we are going to put a bar on it. Yes, we can also write it without an operator. It also means that we are performing an AND operation. Next is our XOR gate. XOR gate is again somewhat similar to our OR gate, but the only difference is that we are having two curved surfaces. Two curved surfaces. Again, there are two inputs and one output. So it will become AB and the output is X. Hopefully you got these 6 gates and you will be able to draw or construct these gates. So in the beginning of my lesson or in the start of my lesson, I told you about truth table. So this is a form of truth table, although I'm going to touch this topic in my next lecture, but just for your understanding, there are several inputs. You can see here, these are the inputs. And from these inputs, depending upon the gates, we are going to generate out. Got it? When we have two inputs, so the possible combination are 2 power 2 is equal to 4. We are just applying power rule. You can see here 1, 2, 3 and 4. 4 possible combinations are there. Both the bits are 0, one is on, other is on and both are on. These are the 4 combinations. When we have 3 inputs, yes, there is a possibility that we can handle 3 inputs. So 2 power 3 is equal to 8. So you can see here that we have 8 inputs here in this table, 8 input combination. So every combination is different from each other. Although we will just reinforce this topic in our next lecture, but for your understanding, I have just introduced the topic of truth table here as well. Next thing is, this is the major question that comes into your exams from logic gate question, that you need to construct a logic gate from a Boolean expression. So it's very simple. You can see here how many inputs are there. 2 inputs you can see. Here in this expression, there are only 2 inputs. And yes, what are we doing here? First of all, we will perform NOT operation. So I am going to draw a NOT gate in front of B. Then we are going to perform this part. So in AND, there are 2 inputs, one from NOT B and one from A. So there are 2 inputs going to this gate, and definitely there must be a line emerging out of it for generating output. Okay. Now next portion is we need to construct NOT A and B. So we will we will drop a line here and we will construct a NOT gate, right? And from B we are going to draw one more line. So again we are going to enter it into AND gate. So you can see here NOT A, this is one gate, and B, this is another one input and another input, and this is going to pass through this gate. Now the last step is both the output generated from these two gates, intermediate gates, we are going to add it into OR gate. So this is the way that we can construct a logic circuit. This diagram is known as logic circuit, and this expression is known as Boolean expression. This expression is known as Boolean expression. So what we did so far, we are able to construct a logic circuit from a Boolean expression or Boolean expression. Okay, so that's all about today's lesson. What we have learned in today's lesson, what are the logic gates, basic logic gate symbol, and how can we construct a logic circuits out of it. So this is the question that has been given to you to solve. Please, you can share it with me, and yes, I can provide you the feedback accordingly if you are able to draw it, or if you are facing any problem, you can send me a message in the form of comment. Keep watching my channel and videos and subscribe it. Thank you very much.